Assalamualaikum and a very good day. Today we are going to explain about our multi-stage amplifier design and we are from group 2. So in stage 1 we have common source self-bias bypass RS, and in stage 2 we have common source voltage divider which is also bypass RS. Given value from the assignment guidelines, also since the highest ID in our group is EA18088, so the total gain is also 88. Given RL is equal to 2.7 kilo ohms, R6 1 kilo ohms, Vs 50 millivolts, and frequency 1 kilohertz, VDD 12 volts, Z into equal to 10 Z in 1. Value from the datasheet, we have IDSS 20 milliampere, YOS 40 microsiemens, YFS 6.5 microsiemens, and VP minus 8 volts. Start with the calculation of AVT. AVT formula is equal to AV load 1 times AV load 2. So here we assume that AV load 1 is equal to negative 8 and AV load 2 is equal to negative 11. So that we have AVT is equal to 88. Loaded voltage gain stage 1, CS self-bias bypass RS. RD equation is equal to 1 over YOS. So we substitute YOS. We got RD is equal to 25 kilo ohms. AV load 1 formula is equal to Z into over Z into plus Z out 1 times AV no load 1. We substitute all the formula here and expand AV no load 1 formula equal to negative GM VGS times RD parallel RD over VGS, and we cancel out VGS and substitute all formula. We got RD is equal to 1284.30 ohms, and following the standard value we have RD is equal to 1.3 kilo ohms. We have so Z out 1 is equal to RD parallel RD. Z out formula we expand and we substitute the value of RD and RD. We have Z out 1 equal to 1.24 kilo ohms, and here we assume RD is equal to 10 mega ohms. Z in 1 equal to RG equal to 10 mega ohms, and AV no load 1 formula negative GM VGS times RD parallel RD over VGS. Substitute the formula and we have AV no load 1 equal to negative 8.06. So this is analysis at stage 1. GM is equal to 6.5 millisiemens and have GM formula equal to 2 IDSS over VP times 1 minus VGS over VP. Substitute our value and rearrange the equation. We have VGS equal to minus 2.4 volts. Using Shockley equation, ID equal to IDSS times 1 minus VGS over VP square, and substitute the value. Also we have ID equal to 9.8 milliampere. So when we want to calculate RS, we're using Gabriel equation. VGS equal to VG minus VS, and VG is 0 and VS is ID RS. So VGS equal to minus ID RS. RS is equal to minus VGS over ID, and substitute the value. We have 244.898 ohms RS. So following the standard value, we have 240 ohms RS.
Okay, next, moving to the loaded voltage gain stage 2, common source voltage divider bypass RS. So before this, we calculate RD is equals to 25 kilo ohms, and we know that the formula for AV loaded 2 is equals to RL over RL plus Z out 2 times AV no load 2. So we expand the AV no load 2 equation and we substitute the value RL, RD, and AV loaded 2, and we calculate that RD is equals to 5538.98 ohms, which equivalents to 5.6 kilo ohms following to the standard resistor value. So next we calculate the Z out 2, which RD parallels with RD, and we got the answer is 4.58 kilo ohms. Since Z into is equals to 10 Z out 1, so we times the Z out 1 with 10s and we get the Z into equals to 12.4 kilo ohms. Next, we calculate the AV no load 2 and we expand the equation and we substitute the value for GM and we cancel out the VGS, and RD parallels with RD is equals to 4.58 kilo ohms, and the AV no load 2 is equals to minus 29.77. DC analysis at stage 2, we assume that R1 24 kilo ohms and Z into 12.4 kilo ohms, and then we substitute the R1 and Z into the formula to get the R2, and the R2 is equals to 25.66 kilo ohms, which equivalents to 27 kilo ohms. So next we calculate the VG, which is VG is equals to VTH, and the VG equation is equals to VDD times R2 over R1 plus R2. So we substitute all the values and we got the answer for VG is equal to 6.35 volt. Finding the RS, we apply KVL equation, which is VG minus VGS plus VG plus VS equals to 0. And then we rearrange the equation until we get the RS at the left side, and RS is equals to 892.86 ohms, equivalent to 910 ohms in the standard resistor value. Next, calculation AVS. AVS is Zin 1 over Zin 1 plus R6 times AVT, and we substitute all the value that we get before, and the AVS is at 87.991. Since from the before our calculation before, so we verify that all of this, Okay, next, this is the final multi-stage amplifier circuit, and the second stage system. So that's all from us. Thank you.